All right. Hey, everybody. Thank you so much for coming. My name is Dashun. I used to live in this building, recently moved out. So great to see everybody. So it's my real pleasure to introduce Morgan Frank here. As you see, I know him so well that I realize I don't even need my phone to read your bio, but Morgan actually touches many branches of complexity, and should be very familiar to many of us in this community. When he actually first grew up from Vermont, working with the Vermont complex system crowd, and then he went to grad school at MIT Media Lab, working with Yad Rawan. That's where he started this line of work with future of work and AI and complexity. After his PhD, I should mention we tried. I in particular tried very hard to recruit him, and he decided to spend his post PhD at a lesser place than us, which is MIT Media Lab with Sandy Pentland. And then since then, he moved to University of Pittsburgh and the School of Information, where they have actually a quite nice group of people where I just visited them a couple months ago, group of them that all work on this intersection of complexity, social science, and computational social science more broadly. So great to have you here, and we're excited to hear what you have. Right, thank you.
Thank you so much. All right, thank you for the nice introduction. Like Dustin said, I'm really excited to tell you about some of my work. Looking at AI, complexity, and the future of work. This is a body of work that indeed started while I was a PhD student, and I'm sure I tested out parts of it on Dashun throughout the years. So I'm happy to share everything now. I was just curious, how many of you are doing work looking at AI and its implications in the workforce? Very excited.
Hi, I think I heard about it.
Sure. So there we go. Yeah. Much better? Okay, great. Cool. All right. Interesting to see. All right, so let me tell you about this. So why focus on AI and its workforce implications right now? One reason is that there is a lot of concern in the public domain. Let me highlight some headlines from notable business sources. Here we have headlines from CNN Business, Business Insider, and Forbes magazine saying things like 300 jobs could be affected by the latest wave of AI. ChatGPT may be coming for our jobs. What does ChatGPT really mean for your job? You can imagine that with headlines like this, the public is worried about what AI means for their job security and what they will be doing in the future of work. But the public narrative is not so clear on this issue, actually. To try to highlight this, on the right, I have two additional news headlines from, again, notable news sources that occurred about a month apart. The first is from The Atlantic that says how ChatGPT will destabilize white-collar work. And then about a month later, you get a headline in Business Insider saying ChatGPT is the MySpace of AI. It's fun, but it's far from taking your white-collar job. So who's right? How can there be so much confusion and so much uncertainty, even while at the same time there are a lot of alarm bells going off? Fortunately, we should be able to answer this question. There is at least a decade of peer-reviewed research trying to estimate which workers, which jobs, which skills might be automated by tools like AI. So can we use that body of literature to solve this problem? Here's one very well-cited study that I think kind of starts off the modern wave of research in this area. This is the Fry-Osborne study out of Oxford University. It was published as a peer-reviewed article in 2017, but first appeared as a preprint in 2013. They made some assumptions about what kinds of skills represent bottlenecks to automation from computers, and then combined expert opinions with those bottleneck skills to arrive at probabilities of computerization for every occupation in the US. They then said how many people in the US have each of those job categories, and concluded alarmingly that 47% US employment is at high probability of computerization. How do we know that their scores are any good? The only kind of empirical validation that they offer is to compare which occupations have this high probability of computerization with their wages. They're finding that low-wage occupations have more exposure. And how much educational requirements are there for different job titles, finding that occupations with greater educational requirements are less exposed. Some of the assumptions for this study from a decade ago might not make sense. They definitely weren't talking about large language models or generative AI a decade ago. And in fact, one of their assumptions is that creativity is one of those skills that's a bottleneck and will never be automated because it's hard to write down rules about how to be creative. Now, at least by some measure, large language models, generative AI, they're doing creative work, at least by some definition. So maybe this isn't the right study to use. Like I said, though, there's been a lot of studies since then. Here, I'm pointing to a paper published in Science in 2024. Preprint appeared in 2023. This is work from Daniel Rock, who's at the Wharton School at Penn. He was working with some of the data scientists at OpenAI. They surveyed people, asking them what workplace activities they think LLMs could do. And then also cutely, they asked the ChatGPT to self-assess. What workplace activities do you think you could do? What kind of validation do they offer for their scores for which occupations are exposed to automation from large language models? First thing is that human assessment is basically correlated with the ChatGPT self-assessment, so that's cool. And then in terms of empirical validation, what they offer is that high-wage occupations have more exposure to LLMs. And this chart's a bit busy to read, but I'll just skip ahead and tell you that occupations with greater educational requirements have more exposure to LLMs. So this is completely the opposite of the Fry-Osborne study. Luis?
That first graph is to be expected, right? Because they were trained on human-created material.
I think so too, but it would have been, I think it's more of like a sanity check to them. But you're right.
I mean, if it had not been correlated.
That's right. Would have been more interesting.
Very,
would have been more interesting. So here, which of these, let's say you're curious which jobs moving forward might be lost because of LLMs. Which of these studies would you use? Whose estimates would you use? I guess you would pick Daniel Rock's study because they were focused on LLMs, and LLMs didn't exist in 2013 like they do today, and that's a good reason. But aside from this sort of theoretical argument, if you were forced to pick based on empirics and validation, I don't know that saying that this is more predictive of wages or more predictive of education or positively or negatively associated with wages and education, I don't know that that creates a very good basis for picking how we should recognize workers who might lose their job because of AI. I think if you asked Daniel Rock this same question, which study you would use, he would say you should use neither, actually, because they're not designed to answer that question. So one of the things I want to do is talk to you about some of the work I've been doing, trying to build a more generalized framework for how skills impact workers' resilience and adaptability to disruption, AI being one of those sources of disruption. And then talk about what we've been doing, how we've been using that framework to try to better understand where workers need support and where workers can adapt to disruption. So first, how do we think about skills and how skills might mediate workers' career options in the face of a disruption from AI, let's say? There's a lot of theoretical work in this area. The big theory in this space is skill bias technological change, which I'm going to grossly oversimplify and say in broad strokes. This theory says that non-routine cognitive workers tend to be made more productive. So a computer programmer is more productive by machine learning. All of you are more productive because of machine learning. While other workers who do more routine or physical work tend to be substituted by technologies. So a truck driver might be perfectly substituted by an autonomous vehicle. And this has proven to be a very useful framework, basically a first-order approximation for explaining who has negative exposure. But I think that if you sort of look between the lines, you'll find that there are some examples that don't fit well within that infrastructure. So what I'm going to do now is show you two cute illustrative examples, completely cartoonish, but I think they will help you understand how I'm thinking about the shortfalls of this theory. All right, so here's the first video. We're doing this over Zoom, so the video is a little choppy. Okay, so here you can see this really cool robot. And the first reason I'm showing it to you is because this video is just amazing, right? So you have this robot balancing on two wheels, navigating the warehouse setting, carrying boxes, stacking them, destacking them. You can tell that there's clearly a plan to all this. So I want to ask you now to imagine that this robot becomes a practical solution for warehouse work. What would that mean for warehouse workers? Well, to help you answer this question, I've provided some comments below the YouTube video here. Now, sure, YouTube is not a recommended source of economic forecasts, but at least here you can see the comments are pretty negative. They don't think this is a good thing for warehouse employment. Okay, so this falls well within the SBTC theory. Here's another, again, completely cartoonish example. So here we see a artisanal good produced by a high-skilled worker. Here we see two unskilled workers. But using technology and these unskilled workers, we can produce this artisanal good. Okay, so I don't actually think that this is how we will produce dance, but let's just imagine that this became the practical way to produce dance moving forward. I think that what would happen here is that wages and employment for the high-skilled ballerina would be depressed, while employment and wage opportunities for these low-skilled, in this case, they're actually computer science grad students at UC Berkeley, so I think they're doing fine, even if not in dance. But I think it would mean more opportunity for them because they can work with technology. So this seems to go against the SBTC framework. So these are two cute examples, but we can be a little more concrete about this. If you're forced to characterize occupations into the traditional bins of being cognitive, physical, routine or non-routine, high or low wage, then you're forced to put really different occupations into the same bin. So for example, medical surgeons, civil engineers, high education, high wages, cognitive, non-routine, no transferability of skills from one job to the other. Probably there is nobody moving between these occupations in their career without significant reskilling. And the types of technology that these workers are going to interact with are likely to be very different as well. Yeah.
Question about the video, the first one in particular, because I really thought that you were going in a different direction with it. So one of the things that was notable to me was how slow and awkward the robot was. I mean, a human would have been zooming through that task, right? And it would have learned much faster. It's kind of easier and cheaper to replace a human worker. So I actually see that kind of skill as kind of being very, very uneconomical to replace a human by a robot. What would you say to that?
So I'd say two things. The first is you're right. You don't see warehouses deploying that robot in particular. I think in part because there's regulatory and safety concerns, and that's part of what you're getting at there. When you're not so used to how that agent will move in that environment, it becomes a safety hazard. And I asked you to imagine it became a practical solution. And of course, we're not quite there. My second answer is that I really think that robotics is moving in a way where robotic solutions will not look human in their answer. So some of the recent videos from Boston Dynamics, for example, they have a new humanoid bipedal robot that they show in this warehouse setup, and it's solving a problem in a way humans could not, because it can do things like rotate its head 180 degrees or go from holding something like this to holding something like that. And it can move joints in ways that humans just can't. So its most optimal solution looks non-human in some of these settings. So that could be another way that we see robotic solutions maturing moving forward. Okay, another very well documented example. Those of you who have done research in AI and future of work may have heard of this before. So I'm looking at you, Mo. You're going to abstain. What do you think happened? And maybe Deshan, maybe you abstain. What do you think happened to national employment for bank tellers as automated teller machines were adopted across the country? There's three options. Employment went up, employment stayed the same, employment went down. Give you a second to think about it. Okay, who votes for employment went down? We got a couple. Who votes for employment stayed the same? Much more for that. Who votes for employment went up? Okay, so like 4 or 5. The answer is employment went up across the nation, and there's 2 reasons. The first is that indeed each bank branch employed fewer bank tellers on average, but more bank branches opened up because ATMs made it cheaper to operate. And so more bank tellers were employed on aggregate. The other reason is, I think, much more interesting and more nuanced and hard to explain with things like demand elasticity. The other reason is that the skills required to be a bank teller fundamentally changed from money handling and numeracy skills to instead requiring workers who can perform social tasks and negotiation and sales. So if you are just pulling some money out, you could do that on your app today, or you go to the ATM. But if something's wrong with your account, by golly, you're going to go talk to a bank teller, aren't you? Or if they want to try to sell you a more complicated thing, a savings account, a high yield savings account or something, you have to go talk to the bank teller for that. So the skills required to be a bank teller changed as a result of this technology. So again, to understand the difference between surgeons and civil engineers and how they'll experience the future of work, to explain how bank tellers were changed because of ATMs, the story is at the level of skills. So actually with your colleague Matt Groh, we were trying to figure out what is and Deshun also, we were trying to come up with what is a big framework that allows us to try to encapsulate both the microscopic and macroscopic dynamics. And so here I'm imagining that the US labor market is basically a multi-layered complex system. At the top, you have different labor markets. You can think about these like different cities or different regions across the US. Each city, you might represent the workers there as an employment distribution. How many workers of each job title are there in that city? But you can do a bit better if you're able to actually model people's ability to move between different employment opportunities within that city. So the connections between occupations as well. What things might create those connections between occupations? There's a whole lot of them, like who you know, for example, but one of them is skills. Do you have the right skills to move from one job to another employment opportunity? And skills don't exist in isolation either. Some skills are more valuable when bundled together, like math and programming, compared to when you have them separately. And this is not true for every pair of skills. I don't see the added benefit for being really physically strong and really good at math, for example. So we have this multi-layered complex system, connections within each of the layers and connections between each of the layers. And our idea in this PNAS perspective article was that if we could actually map out these cartoon-ish layers with empirics, we would have a better opportunity to understand how technology impacts the demand for specific workplace activities and skills, and how these little microscopic changes to the system create the macroscopic things we talk about today. Things like skill polarization, job polarization, greater urbanization, and things like that. So today what I'm going to try to do is tell you about some of my work to fill in the cartoon. And to begin with, we're going to focus on that rightmost layer. How are skills bundled together? Does skill polarization underlie job polarization? So this layer. So to do this, we're going to use data from the US Bureau of Labor Statistics. They have what's called the ONET database. They go out and survey workers and experts and ask them how important different skills are to their daily job. We aggregate those responses to relate different occupations, you can think about this like job titles, to the skills that are important to those occupations. And by looking at which pairs of skills co-occur as important across many occupations, we can say which skills tend to get bundled together. In truth, when we do this, we're going to use the revealed comparative advantage normalization. This is the same stuff from Ricardo Hausman and Cesar Hidalgo's work. What this allows us to do is basically penalize for skills that are ubiquitous and identify the skills that are distinctive of one occupation compared to all the other occupations in the labor market. And so when one of those skills is distinctive, its RSA value will be greater than 1, and we'll say that that skill is characteristic of that occupation. Some examples of ubiquitous skills are things like interacting with peers, interacting with supervisors. Those are things that almost anybody does, as long as they're working with other people. So, like I said, we were basically just mimicking Hausman and Hidalgo. They produced this product space that has this dense center of complex goods like computer parts and chemicals, and a sparse periphery with extraction goods, things that any national economy could export, things like lumber and fish and so on. So we were expecting to see the same thing, complex skills in the middle, sort of skills that anybody would have on the periphery. Here's what we actually see. It's quite different. Instead of this core periphery structure, instead what we have are these two clusters of skills. In general, on the right, we have sensory physical skills, so things like manual dexterity, physical strength, low light vision, audible skills. Those are all things you'll find on the right-hand side. Skills on the left tend to be more social and cognitive in nature. So math, programming, persuasion, negotiation, all skills that are on the left-hand side of this space. So this is really interesting. The data is telling us that there are two major clusters of skills. We didn't seed for that. We just said let the data tell us. It could have been no clusters, 10 clusters. The data is telling us there are two. What can we do with just those two clusters? As a first pass to give you a sense for how this might be useful, what we're going to do now is take job titles, occupations in the US, and with black circles, identify the skills that are characteristic of each occupation. So here you see dishwasher, almost all the black circles are on the right-hand side. This indicates that dishwasher requires a lot more sensory physical skills compared to occupations elsewhere in the economy. We do this for occupations with higher and higher annual wages, and you can observe this smooth transition from relying almost all on the right to relying a little bit balanced between the two, to relying almost entirely on skills on the left. So this is a nice first pass, because remember I was doing this as a PhD student at MIT, and there's a lot of labor economists who are interested in the hollowing of the middle class at that time. So David Otter is an economist there, and he's sort of the biggest voice in this space. And I think there's a strong relationship between our data-driven exercise and the careful theoretical work that David's been doing on this. So what is the hollowing of the middle class? Here's one plot from David's work to help explain it. Here you see 3 lines representing different decades. Within each decade, he ranks occupations by their mean wage and says within each of those bins, what was the change in employment share over the course of that decade? And he argues that in general, there's this U shape indicating that employment share for the middle class diminished, while employment share for low skill and high skill occupations increased. Now, if any of you listened really carefully, you'll notice that there was a bit of a sleight of hand. There's a bit of a change. The theory behind the hollowing of the middle class has to do with skills. And in fact, he labels this axis skill percentile. But the way that he approximates skill is wages instead. So what are the low skills, the middle skills, and the high skills? In David Otter's analysis, you don't really know at the perspective of skills. On the other hand, our analysis, we found that occupations that rely on the left, those are the high earners. Occupations that rely on skills on the right, those are the low earners. So we have a data-driven answer to what are low skills, middle skills, and high skills. Again, imagine me being a PhD student, being very thankful that I don't have to argue with David Otter, and we could instead be like, look, we found this cool thing. It works with your theory. No. So I was happy with that. But what else can we do? That's really just leveraging the community detection. But we have all this information, all these connections between pairs of skills. What can we do with that? So to use those skills, we're going to use them to explore how workers move between different occupations over the course of their careers. And we're going to use skill similarity between employment opportunities to try to model that. So in particular, we have now our skill network to help us try to approximate that bottom rightmost circle. What can we say about this middle layer, the connections between occupations? So again, we're going to rely on ONET for this, and I just want to drive this point home that focusing on specific skills is really important if you want to understand workers' career mobility compared to a traditional paradigm. So here, for example, we have air traffic controllers and medical surgeons. I'm using word clouds to try to just exemplify what skills are most important or least important to these different occupations. So you can see, for example, that air traffic controller, time sharing, selective attention, those are things you want for air traffic controller. For medical surgeon, manual dexterity, definitely want that from your medical surgeon. So the skills are quite different, as you would expect. But when you're forced to characterize them in simple terms, like how cognitive is this occupation, they are identical. So you really need the specificity of these skills if you want a more complete picture of how much overlap there is in the skill sets, and therefore how likely it is for a medical surgeon to become an air traffic controller or vice versa. So what we're basically doing here is using a real value card similarity, saying how many skills are shared between air traffic controllers and surgeon. In fact, there are a few, and how many are unique to one or the other. So this is sort of a data-driven example to help you understand how this might work. I did see that there was almost a mid-air collision at Midway yesterday. My friend texted the video to me while I was driving to the airport to come visit you guys, so very thankful for that. Maybe we do want medical surgeons doing air traffic controller. I don't know. Probably we don't pay them enough. Okay, so is this skill similarity useful for actually predicting how many people move between employment opportunities? Here, we're going to include that as the skill similarity score here. It's just one variable, and we're going to compare its predictive performance to some baseline models. The first is just a random mixing model based on national employment, and then a random mixing model combined with a skill similarity score using a simplified similarity taxonomy, or skill taxonomy, just measuring how cognitive, physical, routine, or non-routine each occupation is. And what you can see is that there's a pretty good improvement when we try to make predictions about the number of people moving from job A to job B nationwide when we use the skill similarity score using this much more detailed set of skills. To show that this is not just splitting hairs, like maybe 4 skills is too simple, maybe you need 8 skills or 10 skills, and I'm just making a big deal over nothing. To show that that's not the case in this plot on the right, what we're doing is rerunning model 3, but for what we're doing is we're selecting some number of skills to randomly select from the full set of skills and using just those skills to calculate skill similarity. And you do that a bunch of times for each number of skills, recalculate skill similarity, run model 3 and say how predictive is it. And what you can see here is we get a very steep improvement in our predictive performance with, let's say, the first 50 skills or so, and then modest improvement thereafter. So what this suggests is that you really need that information from the detailed list of skills to do what we're seeing in model 3 and 4 here. And there's some modest improvement when you get up to the full set of skills. Maybe we could do better if we had even better information representing workers' workplace activities and so on. So that's something we're working on moving forward. Maybe I'll talk to you about that if there's time at the end. So anyways, our skill similarity score seems to have some predictive power related to career mobility. I'm happy with that. Let's use that to to try to model the connections between occupations in different cities' labor markets. So here, what we do is we actually create a whole national occupation network where here now nodes are occupations or job titles, if you like, and they're connected by a weighted edge determined by their skill similarity score. So there's one network with all the occupations, but it turns out that not every city supports every occupation. So what we're going to do is highlight sub-networks based on the occupations with non-zero employment in each city in each year. So you can see Burlington, Vermont, pretty small city. Like Dashun said, I spent some time there. There's some gray circles here. Those are occupations that have no employment in Burlington. So now we wonder what kind of career opportunities are available to people based on their skills and their location in these different networks. And to try to model this, we propose a measure that I call employment-weighted embeddedness. You can think about this like pick some node in the Burlington network. How similar are the skills to other occupations in that city, and what share of the employment in the city is represented by those other occupations. So we're trying to approximate how many other people in your local labor market have similar skills to you. That's what we're trying to measure. Now, one question you might ask is this employment-weighted embeddedness something you want to increase, or is it something you shy away from, something you should decrease? Is this a measure for complementarity, so you could find agglomeration of benefits? Or is it a measure for competition, indicating that you might want to do something else with your skills? To try to explore this, we have a few data sets from a few different private vendors, each containing the resumes and thus the work histories for millions of workers in the US. And we're going to look at how people actually change their employment-weighted embeddedness as they make career changes in their resume. To highlight this, I have my resume as an example. There are basically 3 types of changes we're looking for. The first is that you can have the same occupation but move to a different location. I was a research assistant at UVM. I became a research assistant at MIT. The second is you have a new occupation but you stay in the same city. I became a postdoc at MIT. And the third is you could change both categories. So I went from being a postdoc in Boston to being a professor in Pittsburgh. And so you can see that these networks for the 3 cities throughout my career history are quite different. And you can imagine that I was making moves between different nodes in these networks as I made these changes in my career. So what do people do? Interestingly, what we find is over the course of people's careers, the tendency is to actually decrease employment-weighted embeddedness as they go. Why might they do that? we find that individual job transitions that decrease employment-weighted embeddedness are more strongly associated with wage increases as they go. And this is true even if we control for things like, were you changing the job title? Were you changing the city? Was there a difference in the educational requirements from your first and second occupation? We try also looking at some more generic network properties, like how central in terms of PageRank is your occupation to your city's network. And even with these controls, this result persists. So what do we think is going on? We think that employment-weighted embeddedness is basically measuring a relative skill specialization relative to your local labor market. And so if you are able to get those specialized skills, you'll have lower employment-weighted embeddedness, and you enjoy some benefit, some premium because of that. So that's what we think is going on here.
Can I ask, how do you get, can you tell us about the data? Is this individual level? Is it burning glass? How do you know the data of individual transition and their wages? And does this pattern also changes for early career versus later career people?
Yes. So good question. Let me find the right slide here. So these are resumes from Burning Glass, which is now Lightcast, and from one of their competitors, Future Fit AI. And now we actually have in the paper too, we include data from yet a third competitor, Revelio Labs. And basically what they're doing is, I'm referring to it as resumes, but really they're scraping people's profiles from online job seeking websites. So you can think about LinkedIn profiles as an example to have in mind. So that's what they're getting. In the Burning Glass data and the Future Fit data, there's no information about wages, but what you can do is map the job title and the city to data from the BLS to estimate what their wages are. Revelio, interestingly, does have a model where they estimate the salary of each position in each resume. So two people with the same job title in the same city at the same time, but different employers, might have different salaries in their data set. And that's something we used in the actual paper, but I don't know if I have slides on that. Their approach was pretty interesting. They basically used visa applications to build a model to predict salaries. So I thought that was clever. And so otherwise, yeah, we are able to track individuals. Yeah.
This is a clarification question. I'm curious for how you define an occupation. Like when you said that you were going to a new occupation, at least coming from a more sociology or perspective, you were just progressing within the same occupation, right? Like you went from postdoc to professor, like you're kind of going up the career ladder within the same occupation. I'm just wondering if that conceptualization matters for your study on how it changes.
So the easy answer is we're just using occupations that the U.S. Bureau of Labor Statistics uses. So we're using the standard occupation classification system. And I think the deeper question is, are we recognizing that there might be some ordering to people's choice to go from occupation A to occupation B? So of course, it makes sense to go from postdoc to professor. Very few people go from professor to postdoc, even if they might have the skills to do it, right? And the answer is in this project, we're completely punting on this sort of seniority or prestige. It's just really this asymmetric thing. So we're missing out on that dimension. But if you want to learn about that, I know there's this great Nature Human Behaviors paper from Mo that you should go read, looking at the order in which people acquire skills over their careers. So I think that we are starting to now have some data where we could get at this ordering better. Yeah.
So job ordering career, are you considering kind of real jobs as opposed to if someone at a part-time job at McDonald's, does that count in the course of their career or not? So is there any kind of scraping of things that people would not, well, among us, we wouldn't call them as being part of our career path?
Basically, if people list it on their work history, we're including it in this analysis. Other questions? So like I worked at Friendly's, but you won't find that on my CV.
That's what I'm saying, but that could make the results for earlier order kind of mismatch and mixing of the facts.
Yeah, it's true. But I guess this is actually the plot I wanted. But you can sort of see that. So here we're measuring job order and resume. You can see it. You got to go pretty far out before this negative trend starts to flatten out.
Right, but there actually could be something different, which is that earlier on you are actually going into higher embeddedness and then you decrease. Because thinking strategically, that would seem to be the right thing to do, right? Getting more opportunities, and then when you reach a certain level, go for lack of competition. And so I don't know if one of the reasons why we are not seeing something like that could be because of such an effect.
I think that is perhaps what's going on, actually, right? You end up in positions with less specialized skills. And just like skill specialization theory tells us, if you can gain those specialized skills over your career, then you should do that because you get greater negotiating power. So I think this fits that. All right, cool. So I started you with this cartoon. I said we're going to fill it in, and once we do, it's going to be great because you're excited about LLMs, Dashun's excited about computer vision, whatever. We'll just sort of say what skills, what activities we think might be automated, plug that into this big model, and connect everything to what actually happens in the labor market. And what I can tell you is that we have now these empirical representations for these three layers, but I ran into a really big hurdle at this stage, trying to actually get data that represents basically how much disruption there is to individual jobs. I'll tell you some more about what I'm doing to solve that, but I'd say that I'm not quite ready to deliver on this promise just yet. Instead, what I can tell you about is how we can use this framework to talk about resilience in a more general sense. And in doing this, I'm going to be motivated from some ideas about ecological resilience to talk about the economic resilience of urban labor markets. So in ecology studies, one thing you can do is take different species that interact mutually, model those mutualistic relationships as a network, and it turns out that the density of connections among those species in that ecosystem tells you a lot about how resilient that ecosystem is. So let me try to make this connection a little more clear. There's, of course, a lot of work in labor economics about how people find their next employment opportunity. There's job matching theory, and of course, this work won a Nobel Prize in 2010. In its most abstract form, job matching theory looks like this. There are some employed people and some unemployed people, and people move between these two categories depending on this matching function M. And the matching function basically says, how should unemployed people fill job vacancies? And the question is, what should this matching function really look like? In its most general form, people often turn to this random mixing type model. Unemployed people are randomly bumping into job vacancies with some friction determined by gamma, and when they bump to those vacancies, they fill them. So this is pretty abstract, and the economists who got the prize for this theory, they know that. They say that this formulation is a reflection at the aggregate level of the complex and varied patterns of hiring. It misses a couple things, but one of the big things that they say it misses is skill matching. Really what they say is skill mismatch. They're arguing that if unemployed people don't have the skills required for the job vacancies, then both job vacancies will go unfulfilled and unemployment will persist. But sort of the other side of the same coin is skill matching, which is what we've been trying to model with that skill similarity score. So let's see if we can complicate things and get some value out of that. So I'm going to take that job matching equation from before, and we're going to basically blow it up to the extreme, as you might expect complexity people to do. First thing I'm going to do is imagine we're focusing on just Chicago. First thing I'm going to do is it's not just employed and unemployed people, but it's people who are employed in a specific occupation, and then people who are unemployed, but their most recent occupation was J. And instead of that matching function, I now have this much more complicated thing. You still have employed people in some job randomly bumping into unemployed people from some other job, mediated by their skill similarity. I know this is a difference in notation because these are from two different papers, but this is that same skill similarity score from before. Okay? So when you write it down this way, we've complicated it a lot. We now have as many equations as 2 times the number of job titles in your city, and for every pair of occupations, we have a skill similarity score. We got a bunch of parameters here. You could fit whatever you want. But the benefit of doing this is that now it becomes an example of a generalized Locke-Volterra system, which is super well studied in ecological studies or in dynamical systems. So if you took like intro to numerical analysis or intro to chaos, you probably talked about Locke-Volterra systems. So there's a lot of work we can use to help us understand a system modeled this way. Do you have a question?
Yeah. So, I mean, that makes a lot of sense. It does look like LV equation. I wonder about the resilience paper now that I think about this, because in the resilience paper, it's about an ecological network. And so who is whom, that doesn't change. And so the network remains the same. But in your case, it seems like when you apply this to a network setting, in your case, the network will shift. When this automation attacks certain skills, then the overall network is going to change, right? So how do you think about sort of this? Can you actually then apply their framework to your setting?
Yeah, I think so. That's what we're going to do at least. And I think one point to clarify is that when I'm thinking about our network, it's occupations are the nodes. It's not people. And so occupations, they persist, really. Job titles might change, like you said.
But the link between them might change.
Can change. And in fact, in ecosystems, it can change too, just over very long timescales.
Right, that's why I thought their assumption is the network doesn't change for them to derive the universal resilience.
So I think what you have to do is use their type of framework for disruptions that occur at a much more specific timescale than the changes. So actually what we do in the paper is we don't really focus on the automation of skills, because the thinking is that technology changes skill requirements slowly. It's actually not a quick thing. Maybe you've noticed this as there was a lot of hype about LLMs taking jobs, and yet jobs have not disappeared. Or maybe you've noticed it yourself as it's taking you some time to figure out how to use LLMs for your own benefit. And so yes, skills change, but not as quickly as, say, the Great Recession impacted things or the COVID pandemic impacted things. So those are actually the disruptions we're going to look at. Okay. Oh, wait, hold on. Maybe we should make this connection more clear. So like I said, here we're going to use Barabasi's Nature paper. They take an ecosystem and they say, well, if you have different species of pollinators interacting with different types of flowers, then two different species of pollinators that interact with the same flower provide a mutual benefit to each other. They help that plant population reproduce. And so you should create a connection between these two species to indicate that mutualistic relationship. So that's what's happening in these two, taking the bipartite network, project it down into these two monopartite networks. And they argue that basically the density of connections in this bug network is predictive of all kinds of different perturbations to the system. For example, the removal of a plant, the removal of a pollinator, or systemic changes like changing temperatures or changing acidity level. So here in our study, we're not talking about bugs and plants. We're instead talking about occupations and skills. And instead of a bug network, we have our occupation network. So what we can do is take the math from that Nature paper, take this really big complex system of equations, and basically boil it down to just 3 equations that approximate the long-term behavior of the system. Basically what we have going on here is this capital W is basically controlling for the size of the network. It's a normalization parameter in our case. WJC, this is saying pick a job, J, look at all the other jobs in your city. How similar are the skills to you? So this is like the embeddedness measure we talked about before. And then we have our 3 long-term effective equations. So we have effective employment, effective unemployment, and this job connectivity thing. Effective unemployment, it's basically saying what is the employment in your city weighted by how connected it is to other occupations in your city. And it turns out that that gives you an estimate for the long-term employment of that, long-term total employment in that city. Similar type of explanation, at least at a top level, for the effective unemployment parameter. And then the thing we're actually most interested in is this job connectivity parameter, which is basically saying kind of how many occupations are 2 hops away from you on the network. It's kind of what we're getting at. Okay, so it's a measure for connectivity. In the ecological study, that measure for connectivity was predictive of ecological resilience. What about when we apply it to our occupation networks in different cities to measure the economic resilience? We were working on this in like 2018, maybe. So the job disruption to study at that time was the Great Recession. Of course, now you say, what about COVID? What about LLMs maybe? Great Recession was the thing we focused on in this Nature Comms paper. And what we found is that when we calculated the job connectivity in each city in the year before the Great Recession started, cities that had greater connectivity recovered faster in terms of total unemployment in the years after the Great Recession. And this is true even if you have some more generic traditional controls for things like total employment in each city, how many unique job titles are there in the city, how entropic is the distribution of people across different job titles in each city. Even with these more traditional controls for size and diversity, this job connectivity parameter seems to indicate resilience. What about COVID? I can share some preliminary results with you and talk to you about why we haven't published this yet. But you get a similar type of result that when you use 2019 employment and skills data to measure the job connectivity in US cities, the cities with, once you control for city size, the cities with greater job connectivity recovered faster in terms of total unemployment during 2020 to the COVID recession. One of the things that we're holding out on though is, yes, I guess we could publish a paper and say that we get a similar result for COVID. But there was, again, a little sleight of hand that I pulled on you that I would like to not be a sleight of hand. Basically, the idea we have is that these occupation networks tell you about people's career mobility because of how similar their skills are to other occupations in their local labor market. Basically, the idea is that if your skills are required elsewhere in your local labor market, you'll have a greater ability to adapt if you experience a job disruption compared to somebody who's in an occupation that is not well connected to the rest of the network. That's the idea. Instead, we weren't able to test that, but instead what we were able to test was this much more macro implication of that hypothesis. If there are on average more connections in your network, your city should overall be more resilient. That's what we tested. What I would like to do is actually get data on job disruption that's at the city and occupation level. And it turns out, even though that seems like it should be an obvious thing, it's super hard to get that data. So total unemployment, really common thing you can get. You can get that monthly for states or monthly for cities. You can't get it stratified by industry or stratified by occupation. None of that. The argument is usually that, oh, people who are unemployed don't have an occupation. Well, yes, but probably they had an occupation before. And so if you just sort of ignore this bit of detail, then hopefully we can actually do something better. So I think there are some real challenges to actually delivering on this promise of relating the microscopic impact of different types of technology to the more macro things, and also for testing this resilience hypothesis at the actual scale that I proposed it to you. In terms of AI, some of the challenges include AI exposure scores are not really validated against job loss statistics. We saw that with those first two studies. The norm is to look at things like education, wages, and then actually employment changes, not unemployment. And I'm going to show you in a second that that is a big difference. And so we need some better data that allows us to test when occupations experience job disruption from any reason. AI could be just one. Another issue with answering this AI question is that AI exposure scores do not vary across firms, locations, or industries. But you could imagine, for example, that two workers with exactly the same job title and exactly the same responsibilities at two different companies might experience AI differently if there's sort of like a big investment required to work with the AI system, right? So if you're the software engineer at Google, Google is going to buy a license for OpenAI, and you can start using ChatGPT right away. If you're working for a much smaller tech company, maybe they don't buy the license, you don't have access to the same tool, even though you're doing exactly the same job, have exactly the same skills, just in a different context. So that's context awareness. The other issue is that a lot of the data from these studies, they're focused on occupations as the unit of analysis, and that can sort of mask what happens to individuals. So for example, you could imagine a scenario where an employer has people who have been with them for a long time. LLMs start to maybe automate that person's job. The person's very senior, they cost a lot of money, so you fire them, and then you hire somebody right out of school who knows how to work with LLMs and costs a lot less. In that scenario, the same job title might have the same employment or more employment or less employment, I don't know, but there was this churn that happened that you completely missed in the employment statistics. So we need some data that actually follows individuals. So I think resumes are sort of a nice way to get at that. One of my strategies for trying to solve this is I was really frustrated by this unemployment data thing. And COVID happened, so I had a lot of time to just scour the internet and email all my econ friends, and even like I emailed David Otter, I emailed Daron Acemoglu, I emailed Richard Freeman saying, is there data doing this? And they said, no, it doesn't exist, which sounded ridiculous. So instead, what I found is that there is some data you can get. In fact, I've been able to get data from each state's unemployment insurance office detailing every month the most recent occupation of everyone who receives unemployment benefits in that state. So what we can do is combine that with employment statistics for occupations in each state to measure the probability that somebody with a given job title will claim unemployment in that state in that month. And I'm going to call this probability unemployment risk. And I think this gives us an opportunity to get over this hurdle. It's something we're working on now. We have a paper in review in PNAS Nexus. And just to show you that this is not, that increased unemployment risk is not the same as decreased employment, I have some examples here. So here what we have is in black, we have annual employment share for some occupation state pair over time. In red, in light red, you have the monthly unemployment risk for that same occupation group in that state. And then in red, you have the smooth annualized version of that to make it more comparable. And what you can see here is that you might expect that employment and unemployment risk are just anti-correlated. If employment is up, unemployment risk is down. And actually, that's not always the case. For example, computer math workers in Nebraska experience growing employment and growing unemployment risk at the same time. For management workers in New Hampshire, there's basically no relationship between the two. And in fact, if you look at every pair of major occupation and state and do this type of exercise, the correlations between employment and unemployment risk over time span all the possible values. Sometimes positively correlated, sometimes negatively correlated. So there's not a concrete relationship between the two. Another thing you might say is, well, maybe individual occupations unemployment risk is largely driven by total unemployment in that state. And in that scenario, it's just big systemic factors are the major thing you need to pay attention to. We really don't need to break it down by occupation in that case. But again, this isn't always true. Here's an example on the top right, looking at the unemployment risk for life, physical, social science workers in Wisconsin compared to the total unemployment rate each month in Wisconsin over time. You can see in this case, they're not really connected to one another. So yes, often they're strongly correlated, but not always. You can also start to see how this might be an important difference when you look at March 2020. So this is, peak COVID in the US. If you were a policymaker saying, I know that frontline healthcare workers need our help. I want to know where in the country we need to funnel that help. Maybe I'll look at total unemployment rate to figure out which labor markets are in the most need. Here's the map you would be looking at, states colored by total unemployment rate. But instead, here's the map for March 2020 of the unemployment risk for healthcare support occupations. They're not really the same. You would do a much better job targeting healthcare support workers using unemployment risk. So I think there's a lot of opportunity to use this moving forward.
The memory that you are having about careers, right? Because I think you are looking at it as a Markov process. You know about the last position that someone had, but especially when the economy is bad and people are firing, they may take a job in the meantime that is not what they desired. And it's not like the connections or skills have disappeared. And I wonder to what extent kind of making it Markov, but 2 steps or something like that could actually reveal additional opportunities or risks or something like that.
Yeah, I think it would be better if we included that in the model.
I know it's much harder to do it.
It's way harder, but we have resume data, so we have the potential to do it.
I think you have the data.
Yeah.
And it would be at least interesting to see to what extent does the market for that you have that skill, right? Is
Yeah.
it time? Is it number of changes?
You're totally right. This is a great question moving forward. One of the things we're working on is with Mo again, a more adaptable framework that allows us to include things like not just the skills of your past, but also where you were educated, what you majored in, and what kind of skills are implicit to those things. So I think we're building a bit of machinery to help us get at the question you're asking. Oh yeah, you're right. We were oversimplistic here.
I mean, fascinating work. I wanted to confirm that I understood correctly what you said.
Yeah.
What you are thinking about. Fascinating stuff.
Thank you. All right. So with that, I'm just wrapping up. So I'm happy to take any more questions you guys have.
We have 3-4 minutes for some questions.
Thanks. Very cool to see how you're doing it. I was wondering if you could take us back to the beginning when you talked about the Frey and Osborne paper and then the Daniel Rock paper. I see a lot of similarities also in your approach to there. So maybe just highlighting it back to what theoretically perhaps is maybe you're adding to the overall literature on skills and automation.
Yeah. Basically, I think that it's way too easy to publish these AI exposure type papers. And I have a paper that's, I'm pretty sure it's going to get through in PNAS Nexus soon, where we sort of make this argument more empirically. And the problem is that you can mean anything by AI, maybe computer vision, maybe LLMs, maybe robotics. And you can mean anything by job disruption. Maybe it's just the skills of your job change. Maybe you lose your job. Maybe it's unemployment. And none of these studies are very specific about it. They're all we have like a whole list of them, but they're all very consistent in that what they actually do is, they have some methodology for saying, here's how we'll assign a risk score to each occupation. Here's some example studies that all do this. And we're going to compare our scores to education, employment, or wages at the occupation level. So I think what we need to do is change the norms a bit. You need to be specific about what technology your score is meant to represent. You need to be specific over what time period you think your score will be useful. So like an LLM today might look different than LLMs in 10 years. And you need to be specific about what job disruption is meant to be predicted by your exposure score. One problem is that there hasn't been good data to help you follow individuals or do things besides compared to these three variables. So I think largely there's sort of a resource problem. And so we need to do some work to find those data, build those statistics so that people moving forward have the option to do something that's more specific.
So this is a great slide. It's just when I look at this, actually, I had a discussion with Eric Brynolfsson about this, and this is a criticism of my own work as well, is that when we look at all this, you realize the data cutoff that people use is very early on. Like a lot of these studies, data cutoff was like, 2010s or 2009s. And including our own studies, when we study, AI use in science, our data cutoff was like 2019 or something. And that's really raises the question of, because AI shifts so quickly, and 2019 AI is completely different than today's AI. And every year we feel like, oh, this wave really is different. And I think there's there's emerging consensus that 2022 onward is representing some very fundamental different shifts in LLMs. So that's where, can you comment on how do we think about all these studies so far and how to think about, and to what degree this actually inform our understanding of AI disruptions of today?
Yeah, not very helpful for understanding AI in terms of generative AI and LLMs today. So I compared Daniel Rock's 2024 paper, which is not on this table, but really ought to be, with the Fry Osborne paper. But I could have also just looked at Daniel Rock and Eric Brynjolfsson's 2018 paper compared to Daniel Rock's 2024 paper, and we would have reached exactly the same conclusion. And actually, it's even more concerning because they were looking at assessing suitability for supervised machine learning. And LLMs are supervised machine learning. It's, perhaps bigger than that, and the specifics are maybe different than how they conceptualized machine learning in 2018, but it should fall within the sort of abstraction that they used to build up that study. And in fact, it doesn't. And so we actually have we have a lot of results in this thing that I wasn't intending to talk about today. But basically, there's not a lot of agreement, even among these studies from the same time period, let alone moving forward and talking about a post-LLM time period. So here we're just picking scores from those studies you saw on the table. Some of the studies have multiple scores, so we're pulling all those out, but they're in chronological order. So oldest, newest, oldest, newest. You can see there's not a lot of agreement. And even if you look at specific occupations, each strip is one occupation. Occupations are grouped into major occupation categories, which I've highlighted. Again, here you can see there's a lot of noise within each vertical strip. So not a lot of agreement even within the same occupation. So again, what do I think is going on here? I think these papers differ mostly in their theoretical foundations, and that's valuable to explore. But we need some better ground truth and some better norms around validation and exactly how these scores can be used, both in terms of what kinds of AI, but also maybe where in the country your scores are useful and for what sectors in the economy. We need to have some more specifics like that to get over this hurdle.
Awesome. So I think we're exactly on time. Let's thank the speaker again. All right. Thank you very much, Morgan.